In this video, you're going to be writing test cases for the most complex function we've tested so far, our expenses selector. So this run requires some complex input. It does a whole lot of stuff to manipulate that input. Then we get the filtered and sorted array back. Now, in order to actually test this, we can't just have a single test case. We're actually going to be creating about half a dozen or so to make sure all of the various paths are working as expected. So step one is to create a test file for this one. We're testing a file in the source selectors folder. So we're going to put the test file in the tests selectors folder. Currently, that folder doesn't exist, so let's go ahead and create it. Creating a selectors folder inside of tests. Then inside of selectors, we put the companion test file, expenses.test.js. Inside of here, this is where we're going to write all of those test cases. And the first thing we have to do is just import the thing we're testing. I'm going to import select expenses from, we're going up two folders. We are going into the selectors folder, and there we have just one file, the expenses file. So now that we have the thing we're testing imported, we can actually go ahead and create the test cases. We're going to start off with a test case for the text filter. Let's set up a title for this one. Should filter by text value. And then we can set up the actual test function. So the goal inside of here is to do what? It's to call select expenses and pass in some data. So I might create a const, I can call this one result, and I can call select expenses. Now I need to call this with the correct information. So what is the correct information? Well, the correct information is going to be a list of expenses that we're actually going to be filtering and those filter values. Now, for the expenses, we're basically going to need some test data. We need a list of various expenses that we can use inside of all of these test cases, since all of them need to be able to filter the expenses in order to determine if they've worked correctly or not. So to get that done, what we're going to do is just make an array up above. We can call this one expenses. And this is going to serve as the test data for this file. So it's going to be an array of expenses, and we can use them throughout our various test cases. So to kick things off, let's go ahead and define an ID for the first one. We can just use the string 1, and we're also going to define the other 4 properties. So I can start off with description. I'll set this one equal to something like gum, and then I will set up a note value of an empty string. I can set an amount value of, let's say, $1.95, 195, and finally, I'm going to set a created at value. Now, what is created at for this function? Well, created at is just a number. So all we have to do is provide a number right here. And I'm going to go ahead and start off with the number 0 for this guy. Now this would be the first expense, but this alone really isn't going to help us work with sorting or some filtering. So what we're going to do is just add a few more, and we're going to tweak things so that we can actually filter and sort correctly. So let's see how we're going to do that. I'm going to take this object, add a comma, and paste it, switching the ID over to the string 2. Now I can switch up the description. I will use something like rent. I can leave the note empty. I can then take the amount and crank that up to 1,095 with 2 zeros on the end, 4 cents. And for created at, I can go ahead and put this in the past. So let me take us 1 second in the past minus 1,000 milliseconds. Now we're going to go through this process just one more time, creating a third expense. Then we'll actually write the test cases. Right here, ID of 3. We can go ahead and set a description for this one to credit card. Note can stay empty. For the amount, we could use something like 45 bucks or 4,500 cents. And for created at, we'll toss this 1 second in the future. So now that we have some real test data, we can actually pass that into select expenses with our filters and make some assertions about what comes back. Expenses is going to get passed in as the first argument, and filters, which doesn't yet exist, will get passed in as the second one. Now each test case is going to have their own set of filters, so I'll define a const filters up above. This will just be an object, and each test case can define the filters they want to use. Now, the goal for this one is to actually set something for the text filter, so we're not going to leave it at the empty string, the default value. We're going to switch it up, and I'm going to use the character E. So gum doesn't have E inside of it. It should get filtered out. Rent does. Rent should stay. And credit card does. So credit card should stay. That means we would expect 2 items to come back. I'm going to go ahead and get that done right here. What are we going to do? We are going to pass in the default values for the other guys. So sort by, default value of date. Then we have start date, default value of undefined. And the same thing would be true for end date. Setting it up equal to undefined. So now that we have all of the filters and we've passed everything into select expenses, we can make some assertions about what comes back. What is going to come back? Well, what should come back is going to be an array of 2 items. The first one is going to be credit card. The second one is going to be rent. Now, why is credit card first? Because we do have the default sort by date. So to get that done, we can expect something about the result. We are going to, once again, use to equal. And this time around, we are going to expect it to equal an array. And what are those array items? Well, the first item is going to be the third item from this array. So we can actually just access it right here. I can toss it in. That would be expenses. Grabbing the third item with the index of 2. Then the next one would be the second item up above. So that would be expenses. And you notice that here we're not grabbing the first expense because that one should have gotten filtered out. Now, if we save this test file, the test suite is going to rerun, and you can see that we have our test case passing. So the text filter did correctly filter out that first item, and we have a test case that actually proves this. Now, the next test case we write is also going to be a little tricky. This is going to be one that makes sure the start date filter works as expected. So we're going to work through this one together as well. There are going to be some challenge tests, don't worry. So test right here. We are going to check should filter by start date. We're then going to go ahead and set up the test case function. And what's the goal inside of here? The goal inside of here is to go through those same 2 steps. We're going to define our filters. We're going to pass it in, getting the result back, and then we're going to make the assertion. So I'll start off with the filters. Const filters. I'm going to set this equal to an object. On this object, text will be its default value. So we'll sort by being date. Then we're going to go ahead and actually set up start date, which we'll focus on in just a moment. For now, I'll just leave it as undefined. And finally, we're going to have end date, undefined. So the only one we actually want to change in here is start date. And we know that for this function, we expect start date and end date to be moment instances. So we need to make sure they are. Otherwise, we're going to try to access is same or before and is same or after, and it's going to fail. So it's not enough to just have numbers for the start date and end date. We need moment instances. Now, this is going to create a little bit of an issue. So let's go ahead and explore this real quick. What I'm going to do is right here, create a new instance of moment. And we're going to start it off whenever we want. Let's just start it off at 0. Now, up above, we do need to import this. So we can import moment from moment, import moment from moment. But the problem with our code at the current point in time is that we have items that are just seconds away from each other. So that's going to create weird situations where we can't actually check using start date and end date to filter because we're relying on is same or before after by days. So if we have expenses that are just a couple of seconds away from each other, we're never going to be a couple of days away from each other. So to fix this, we're actually going to tweak the created at values for our expenses up above. Then we'll be able to add a meaningful test case. So let's go ahead and get that done. What I'm going to do right here is leave this at 0. So we can have one of them that is at the Unix epoch, January 1st at midnight. Then we're going to change these guys. So this one, we're going to go into the past, but not just by 1 second, but maybe by 4 days. So we can actually use moment to get this done. I'm going to use moment. I'm going to create a new moment at 0, which would be equivalent to this. Then I'm going to call value of. Now, what is the end result of doing this? The end result is getting 0 back. That's not what we want. So what I am going to do is use another moment method we have available to us. This is subtract. So dot subtract. allowing us to manipulate time. We can subtract a certain amount of some unit. So in this case, I could subtract 1 minute, or I could subtract 4 days. Now I'm going to subtract 4 days from this one, bringing it way into the past. And for the one down below, I'm going to add 4 days. So I'm going to create a moment starting at 0. I'm going to use add to add 4 days. And remember, this needs to be a number, so I will be using value of to get the regular timestamp back. Now we have more meaningful real-world data, and we can actually write some interesting test cases. So for this filter, a start date at 0, I would expect this guy to stay in because they are the same day, and I would also expect this guy to stay in since he's in the future. The only one that should be getting filtered out is the second one. So down below, we can actually pass everything in to select expenses and assert something about the result. Result equals a call to select expenses. Passing in the data, we have our expenses array, which we're going to use, and then we have our filters object defined up above. Now it's time to expect something about that result. What are we going to expect? We are going to expect it equals an array, so I will use to equal. We're then going to provide the array. Now in this case, we, as I mentioned, are expecting this guy to go away, and by default it will sort by date. So we're going to expect the third guy to come first and the first guy to come second. So right here, expenses, accessing the third one, comma, expenses, accessing the first one, not using the second one with an index of 1 at all. Now if I go ahead and save the expenses test file, we should see everything showing up correctly. We have 12 passing test cases. This is going to allow us to spot those regressions in our code. So if we did do some refactoring and we messed something up, like we accidentally read off of the note value instead of the description, we would be notified because the test cases wouldn't work as expected. We could then figure out exactly what seems to be going wrong, track down the issue, and get back to a passing test suite. So there are 3 more test cases that we're going to be adding right here. Should filter by end date. We obviously need to add 1 for that. And then we're going to add 2 for the different ways we can sort. So should sort by date, and then should sort by amount. And I actually want you to knock these 3 test cases out. So for should filter by end date, you're going to do something pretty similar to what we did right here. You're going to pick a random time, preferably somewhere in between, so some of these stay and some of them get filtered out. For the should sort by date, you're not going to expect any of the expenses to go away. You're just going to expect the order to change. So much like we've looked at 2 here, you would just look at 3, putting them in the right order. And the same thing would be true with should sort by amount. So I'd like you to take some time to write these test cases and try to get them all to pass. Please take a moment to pause the video, give this an honest try, and when you're done, go ahead and click play and we'll walk through it together. All right, let's go ahead and kick things off. Step 1 is going to be to create the test for end date. So I am going to set up a new call to test should filter by end date, and we are going to need to define that arrow function for the test case. Inside of here, we're going to be doing something very similar to what we did up above. So if we want, we could feel free to copy this code and tweak it to fit our needs. Nothing wrong with that. We are still going to have a filters object. This time around, though, it is going to be start date that's undefined, and it is going to be end date that has a valid time. So for our purposes, what I'm going to do is pick a day in the future. So let me go ahead and use moment. I'll create a new moment starting at 0, and then I'll use add to add some time on. Maybe I'll add on 2 days. Then, once I do have the filters set up, we can make some assertions about what we would expect back. So this is going to filter out items created further than 2 days away from this point in time. So what's that going to be? It's just going to be this last one, which means we would expect 1 and 2 to be in place and sorted by date. Since this one comes first, I would expect the order to stay the same. I would expect the first one to come first, the second one to come second, and the third one to not be there at all. So right here, first one comes first, second one comes second. Now I can go ahead and actually save the expenses test file, make sure my test suite is passing. I have 13 passing tests, so we are good to move on to the other ones. I'm going to delete the comment for should filter by end date, and I will move on to should sort by date. Should, inside of test, of course, should sort by date passing in that arrow function. And for this one, the filters aren't going to need to change at all. We can leave everything either at its default value or undefined for start date and end date. Once again, we can choose to just take the code from up above and repurpose it down below. I'm going to go ahead and do just that. Now, we don't want an end date undefined. We want to sort by date, and we want to leave a text value of an empty string. So we have all of that passed in. All we need to do is change our assertion. I would expect all three to still exist, just in a different order. So what is the order if we sort by date? Well, the last one comes first, then we have the first one, then we have the second one. So right here, we'll look at just that. First up would be expenses with the index of 2. Then we would have expenses with the index of 0. And finally, I would expect to have expenses with the index of 1. If that is the case, then we know everything is working as expected. I'm going to remove the challenge comment for that one, save the file, and now we have 14 passing tests. This one verifying that we are able to sort by date. The last one we need is to be able to sort by amount. Now, for our purposes, we can just take this entire test case, duplicate it, and tweak it to fit our needs. First up would be the test title, should sort by amount. Next up would be what we do in here. All we're going to do is change sort by from date to amount. And finally, the last thing we have to tweak is the order that things come back in. So what would be the order if we sort by amount? Well, the first one I have right here is my rent. Then I have my credit card bill. And finally, I have my gum. So it would be 2, 3, and 1. I'm going to knock that out down below. First item I would expect would be expenses with the index of 1, the second item, then expenses with the index of 2, the last item, and finally expenses with the index of 0, the first item. And if I go ahead and save the expenses test file, we now have 15 passing test cases. Right here, we have 5 test cases, is it 5? Yes, it is 5. 5 test cases that verify the expenses selector works as expected. Now, if anything were to actually break inside of here, we would indeed know. So if we had messed up our logic down below, or we had broken something in the ternary operator, we would get good information about exactly what broke. So right here, for example, we can see we have some of our failing test cases. Now that we have all of our test cases in place for expenses, we're going to continue testing our application. In the next video, we're going to turn our attention towards our reducers. So we're going to focus on testing those. And once that's done, it'll really just leave our components left to test. I'm excited to get to all of that. So let's go ahead and dive in to the next one.